Okay, here we go. This is going to be glitzy. It's going to be a little shaky, but I'm going for it. Okay, the objective: to display the complexities of the modern world of computer technology in the context of the explosion of the information age, personal issues such as dating, and life choices such as having a career with today's job market, in a socio-political context through scientific and/or mathematical analogy under visual depiction of behavior spectrums from an author who has bipolar disorder traits, grandiose, abstract, and scattered thought patterns, that is also a socially conservative, computer software-minded, male Generation Xer, for a viewer audience who may not know many specifics about computers, job politics, dating politics, or any other in-depth knowledge of the following material. Problem: as time progresses, new variables arise and make previous convention applied in a strictly as-is format fail more and more easily. Solution: new variables need to be incorporated into the equation that can compensate for success. Only through research and evolution can this be done. And there you go. Okay, here's a little quote. The year end of '95, Time magazine has said, these turbulent complexities better than Gates, because he understands, as few people do, where all the money is not the chips or the programs, but controlling over the standards that everyone else has to bow down to, or to which others must adhere. That's what's in a sentence and a preposition. Anyway, there you go. That's it. They said it basically right here, like I said earlier, about the business world, but they didn't really blatantly. Anyway, all right. Okay, problem with the 20th century media. David Kritick of American Solutions said this paper-pushing problems in the 1960s just has got to go. And when I call this paper-pushing problems 1980s, getting an 800 number for a catalog to call for a business or some type of a product or something like that, it gets insane. Moore's law on CPUs arguably applied from about 77, maybe a little earlier, to 2003, which was every 18 months the available processor speed doubles. So if you had a 100 megahertz CPU in the market in January of '95, by the summer of '96 you had a 200 megahertz processor on the market. That lasted for a good while. '90s, I heard a stat that information published doubles every 18 months. I compare myself as a wannabe activist, bad boy, bad shot, hot. Okay, edit this out. Okay, bad boy, hot shot, and this kind of stuff. Bill Gates and Steve Jobs, yada yada. Passive versus active. I think there's a lot of stuff that went their way inherently with the evolution of the market. You got to have somebody convinced that they need you, and then who will be using your software at version 4.0 that won't be at version 1.0. Like a lot of people got onto the internet with Windows XP being all powerful and everything, as opposed to their Commodore 64 and their modem in the 80s, because it was so much more difficult to navigate, with the computer system and everything. There was something, this is a big one I haven't read. Here you go. When graphing calculators came into college calculus about fall of '92, when I was in there, it got stressed that we're trying to stress the actual graphs, the shapes of the figures instead of the numbers of plotting points that we did in high school on pencil and paper. So what happens is I'm trying to make a case I call the hypermedia graphics, that you organize information graphically and you organize it by theme and concept instead of just words. So you have all this, three-dimensional virtual reality, the gloves and the goggles type thing going on. Here's some problems I threw together. Scores of new questions come in developing computer technology and how to handle mass information. Can't search for a theme. Start with an anger core and politics like Gates did in the business world. Rocky tunnel analogy. Okay, I got to explain this. All right. Now, with politics, if you anger a base, you're going to get them motivated, period. If you can anger people, you can manipulate them, okay? Sounds a little kooky, maybe a little dangerous, but it's a fact. Negative motivators are always more efficient. Now, I've never heard anyone say this ever, okay? But one reason why Gates is where he's left Microsoft by now, but Microsoft is where they are now, is because they started in the business world. The business world has an inherent need to crunch numbers, and it yields a profit after it does that. No matter how many aliens Junior killed in Death Blaster 12, the expanded edition, it doesn't generate a profit. But in the business world, it generates a profit, so they make more money because your machines, they can invest more money into you, so you can spend more money to make the next software suite even more powerful, to make them more money, so they can come back to you and buy the next software suite to make you more money, so you can make them more money, and so on and so on, okay? Well, I'm trying to say with some of these trends and dips are going and so forth, blockades, if you will, the rocky tunnel analogy. If you have a gigantic long tunnel that you have no matter how many stalactites and stalagmites are on dips and sways and all this kind of junk all across the sides, the top, the bottom. But if you have one burst of very, very bright light, and that's it. So you throw your lantern out and it hits a big blast of light and it dies. For one split second you can see this. Oh, look what's going to be involved. So you have an idea of what is ahead of you instead of only looking 3 feet ahead of you. Like chess, you got to think about 100 moves ahead instead of just 2 moves ahead like checkers. People are having a harder time finding job happenings today. Their niche, okay, that's kind of there. People today are fed up with dating head games. Determining true compatibility is tougher. That's a good one. In the political process, 1,000 special interest groups are trying to ban or promote something tied to a larger issue. Tons of research is tied to the smallest action. So there you go. And I have some outdated media here. The dinosaurs, what's that rock in the sky while supplies last, from Seiza.com. Our tech support team will be with you shortly, haha. Extinct Media, The Resurrection, also in beta. And I have a vinyl for you. The Dead Music Medium presents a Techno Tombstone, 1973 certified gold. Well, there you go. All right, here we go. Complexity. With my cyber wars, graphics, social interactive, hypermedia activism type thing going on, I want to slosh politics with dating and sexual morality and computers all into one big nasty glob. So here we go. Complexity. The 4 facets of these things I'm talking, these 4 issues or whatever. Politics, computers, career, and dating. Okay, job market sucks, dating sucks today. Computers are going crazy, and politics is always nuts. So here you go. Do this in somewhat of a political context, although it's going to be a little shaky or glitzy. I'm just going to kind of roll with it. Now, the subcategories to the 4 categories. Arguably, it's 2, 3, and 4, and this 2, 3, and 4 is 1 being politics, dating, computers, and career. And something like that. All right, there you go. Here we go. Here's everything categorized: computers, career, job market, dating, somewhat of a political context. Linear versus relatively linear. There's more than one way to skin a cat, which you see in these videos about ASCII versus FCDIC and how HTML was concocted in programming languages. There's thousands of different programming languages, all a different way to talk to the computer, but it gets the same thing done because it always has to be crushed down into 1s and 0s so the computer can understand it. You'll see later on all this kind of stuff. What happens is, within a straight line, picture this as these 2 barriers going in a straight line. Within all this, you have all these scattered different jagged directions you can go in. But when you zoom in on it, it's really a straight line like this. So picture, if you can zoom in on this line, picture inside you have chaos going on in here. But in the broad scheme, in the abstract, it's a straight line because you are moving forward in the technology. It's just a matter of how the micro standard evolves. Basically what you're messing with. Okay, the concept of more than one way to skin a cat comes heavily into play. New complex variables are incorporated into a process, and you debate whether to polish or refine old themes or adopt new ones. Here we go. The initial stage, computers. Just messing with raw data, like they say that with the ENIAC in the 40s, we needed some aggressive needs for crunching numbers to crack German codes of Nazi Germany and so forth. Number crunching, relatively linear technology. Compared to today, yeah, I'd say it was pretty straightforward. As far as functionality is concerned now, I'm sure it's very complex if you're some engineer ripping out the vacuum tubes of an ENIAC trying to get it sucker to work. But, you know, relatively linear. I want to stress this word relatively. Career and job market. Straightforward work, basic goods produced by labor. So then again, I might get back to that relatively linear thing again. You had something like in the late 1800s or early 1900s, oh, the steam engine, ooh, big deal, you know. Lumber, coal, cotton, petroleum product, well, coal, yeah, steam engine, this kind of junk, or food. basically what I call it linear. You didn't have about, processors being obsolete and this kind of junk in 1915 and so forth. Maybe some equivalent of it, maybe, but not nearly as bad. Dating, oh boy. People argue that you had more of a unified moral reference frame back in 1915 or whatever, so differences between the sexes weren't as so pronounced, arguably. Background major denominator for compatibility with most people having similar backgrounds/values. Relatively passive process of courtship. Everybody and granddaddy was married by the time they were 16. You grew up with the person you ended up marrying, Sally Joe Bessie Sue down the lane or whatever. So that was no big deal. Mainstream values, conglomerate, and traditional. So kind of what I said. All right. Next phase. By the way, for computers, this might be 1 decade. For a career and job market, this might be another decade. For dating, it might be another decade or decades. It doesn't happen the exact same year. It isn't like signs of change and complexity. It isn't like all this happened in 1943 in March. I mean, this is just different waves and levels. I'm kind of sloshing them together. Needs for higher level standards, ASCII, certain specific programming language, HTML, hypertext markup language, memory locations for color and other aspects. Becomes nonlinear, if not arguably arbitrary. And what I mean by that is, you'll see later on, I'll get into about the HTML and ASCII, there are certain character values you got to start assigning to numbers. It's arbitrary. ASCII code 32 is the space bar. You could have made it a period or something. It doesn't matter, but what I call them, the arbitrary micro standards have to evolve. Sooner or later, somebody's going to be calling the shots and saying, look, this is going to stand for this. It isn't inherent to the computer technology, so that's where the human input comes in. It starts to kind of demand a more of an artsy mindset, the abstract and software mindset, as opposed to the hardware mindset. Career and job market. You must determine a trade, a college major, or decide what gift or aspiration one has. Presentations and aggressive marketing become a dominant factor. The flashy superficiality of the modern age, instead of just like good old-fashioned linear hard work, that kind of stuff. Dating. Approach and technique in an age that focuses on tangible, visual, and immediate becomes more of a dominant factor in being labeled desirable to the opposite sex. So you have this nightmare stuff where it's all in your approach, it's all in your technique. Instead of genuine compatibility, it's about, whatever jerk looks hot in the suit or this kind of junk. So it kind of takes a turn for the worse here because things are getting more complex. When things are more complex, the opportunity for more damage happens, a newspaper is never going to get a virus like a computer will, that kind of stuff. So when it gets more complex, you have more opportunity for more damage. Original rules practically do not apply. Computers. This gets into the artsy mindset, like for media editing on a Mac or something like that. Possible uses not obvious or inherent to actual technology. Software development adopts a more artsy human psychological content. Career and job market. Rapidly mutating job market. Buyouts, mergers, bankrupt businesses. Must learn arguably multiple job skills or at least multiple facets to a career. This gets very, very tricky and involved in nasty. Dating. Focus on the superficial. Compatibility of subcultures come heavily into conflict, into heavy conflict. What I mean by that is that the modern world tends to bring out micro differences in us, and the compatibility is just focuses on selfishness or grounds for more arguing and bickering and all this kind of junk. Let's see what else we got. Okay, there you go. Okay, here we are. Binary. Ones and zeros, a base 2 number system. This is all that a computer can understand. This is all that a computer will ever be able to understand. Binary, ones and zeros, on and off. You might say, well, it's useless. Well, no, it's not. It looks it, but it's not. Okay, here we go. Hexadecimal versus decimal. Base 16 versus base 10. This is the number system that we're used to. We use as humans. Hexadecimal is whenever you have a base 16. So A is a value of 11. B is a value of 12, and all the way down to F equals 16. 16 is a power of 2, which is, of course, the base 2 binary. So it can be more readily converted to binary than our decimal system. So it's kind of like a higher level of a number system as the computer builds its way to actual words and commands that we can use, and then a graphic user interface with the mouse and the icons to crunch it all back down to a bunch of something meaningful, meaning ones and zeros, so the computer can process, so it can actually do its work. Here we go. Here's a chart, decimal, hex, octal, I think it is, and then binary. Base 2, base 8, base 16, base 10. Here you go. Everything looks like normal numbers except for right here with the hex. 4A, 4B, 4C, 4D, 4E. So there you go. A little sample of hex code for you. I think I have some from an actual magazine. I don't want to get out of sequence here, but okay. Oh, let me go for it. Okay. And there you go. A sample of hexadecimal code ripped straight out of a magazine. I'll probably do the magazine clip later on. Okay, and there you go. A little still shot there for you. I'll just edit this out. So bring us back to this, the OR operator. All we need is one. Okay, bring it back to this, the OR operator. All we need is one gate to be completely closed so the charge, the electricity, 1, will get through to come out with the 1 right here. These can be closed, these can be closed, you know, and all that. And operator is a different story. You need every single one to be valid to get a value of 1. It's like multiplication. If you multiply a 0 times any string of numbers, you always wind up with a 0. But with addition, you can add 0 a million times to 2, and you're still going to wind up with 2. But if you multiply 0 a million times to 2, you're going to wind up with 0. So it's a little bit like that, the AND and the OR. Here are some charts for the gates. The truth table, this is called, algebraic function right here. This is the AND gate and the OR. You basically get 1 every single time there's remotely 1. Okay, the only time you get a 0 is whenever you get everything is a 0. For AND, the only time you get a 1 is when everything is a 1. And then it looks a little more complex when you do something like this, and you're just making tons and tons and tons of these gates and all this kind of stuff, and you're trying to force it. They have a CPU picture right here. Yeah. 2 plus 2 means nothing to a computer. You have to crunch it to 1s and 0s. A 2, a plus, and a 2. Goes to the CPU through certain, I guess, algorithms you want to call it or whatever, channels or whatever. Crunches back to a bunch of processed 1s and 0s, and then other parts of the computer build it from the CPU into a forward that a human can understand. Unprocessed, then to processed. Simplify a little bit right here. 2 plus 2 equals 4. Just straight to the computer deal. And in the CPU, it used to be called a multi-chip module, but that term never caught on because it's really a CPU with a bunch of other components inside of one big chip. So it's inaccurate now to call it just a CPU. It has internal cache. As I remember reading, registers or cache for the cache, which is basically memory buffers kind of for the process. I don't understand it completely. Way too much an engineering level for me. But it's basically help it along and do smaller functions. The math coprocessor, I think once you get past the 386 chip, it's implied it's part of the CPU. But before then, there was a separate unit that you had to work in conjunction with the CPU called the math coprocessor. And a prime example about segmentation and designation of different jobs and tasks in software and hardware. Used to be one thing that used to be was the PCI card for your video was just like another card, like your sound or whatever. Then they started having a special slot for the video because they had special demands and what they call graphic intensive and stuff. And then PCIe was the deal as well. Another slot designated especially for video. It used to take your RAM from your system direct, and now it has RAMs on video card. Higher-end cards have their own cooling fan, just like a CPU. And then there you go. All right, cool. Okay, here we are. This is the flow chart. As you can see, it's very graphical, kind of like the graphic user interface, which we're going to get into a little bit later, as opposed to just what we call hard coding or programming with actual instructions to the computer. You have input a word. If it's longer than 5, keep going. If not, go back here to input it again, because it's got to be longer than 5 letters. If it is, add it to the queue. If that's the end in the program. If not, repeat step 1, go back, keep asking for another word. Now I have right here what we call the pseudocode. And these are the instructions in basically human language of how you make notes to yourself to try to write down the steps. Notice that I did increments of 10 because it's a programming convention that in line numbers, when you use line numbers like in the old basics from the 80s, if you have to go back and put an in-between step, you can call it 15. If you have numbered them here 1 through 7 instead of 10 through 17, you want a middle step in between 1 and 2, you wouldn't be able to do it. Sometimes you might want to go to 100 or 1,000 instead. You never know what kind of lines you have to add in. Of course, in a language like C++, there are no line numbers, so you can just add as much as you want. That got to be a pain in the real world. So take a word from the user, see if it is longer than 5 letters. If it is not, repeat step 10, add it to the queue. Is there another word to type? If so, repeat step 10 in program. If not, I should have said if not in program, but anyway, that's kind of implied. So there you go. And the next Flash demo animated thing should be me doing actual code. All right. And here we go. My crack at programming. You haven't written a basic program, I don't think, in 15 years or something, but we're going to see. We're going to check that out. Okay. You have dim statements and arrays and all that. So I'll call this line 5. Dim a dot. Oh, come on, man. Great. 5. Dim a $. Let's say 100. Okay. Okay. Line 10. Input a word from the user. Input a $. 20. See if it is longer than 5 letters. 20. If the length, len, of a $, oh boy, I'm hitting that wrong parenthesis, okay, is less than 5, then go to 10. There you go. See, repeat. The 20, loop back to 10 if it's unsatisfactory. 40, add it to the queue. Well, I kind of combined steps 20 and 30, but that's cool. Okay, I'll call it 40 to avoid any confusion in the trying to go a little bit than how the numbers correspond. Add it to the queue. So let's say, oh wait, I got a mistake right here. Input B $. Okay, here's the problem. I'm using what's called arguably a temp variable. You have one variable that stands alone by itself to be asked, but you're putting it into a queue or an array, so that's going to be a different variable. I didn't account for that. See, this is a prime example. You're seeing the creative process live or taped, but for me it's live, whatever, as we go. I have not prepared this. Okay, this is a situation we're thrown into, so here we go. 40. Let x equal x plus 1, because I'm doing increments. 50, let a $, x equal b $. So I'm building a queue, kind of, or an array, rather. Okay, basically. All right. We add it to the queue. Now, is there another word to type? So, 60, print another, and then 70, oh yeah, okay, another, and YN for yes or no. 70, input C $, 80 if C $ equals Y, then go to 10. Now, not another. It would be redundant, but if you just put 90 end. And there you go. That's the program. Isn't that cool? You saw it live in the creative process, or taped as it was live, or whatever, in the creative process, and here you go. Let's see if it works. That would be a miracle. Okay, a name. Bucket blue. Another? Yes. Red dawn here. Another? No. There you go. And we got it. This is computer code. We coded right from human English straight to a machine language. And there you go. Pretty cool. Okay, the old days going a little retro for you. Commodore 64. You can go white. You want to change the border black. You gotta use a poke command. If you want to put a character right here, blinking here, like a quote or something, you do poke 1024, 34, which is the ASCII code for a quote. Let me see. If you want to load your directory, instead of right-clicking or clicking on a folder, you have to load $8. Then it fast loads, or at least in the emulator does, and you have to list it, and then you get your directory. And to go back to the beginning of the reboot, in effect, of SY647VH. That's a little retro for you. Okay, starting with ASCII. Again, this is basically trying to build the computer up from a bunch of ones and zeros into something that humans can understand. This is what ASCII looks like. We have a bunch of characters here. 32 is the space bar. 33 is the exclamation point. 34 is a quote. You can do it backwards, and if you print, like in a basic, like an old Commodore 64 in the 80s, print character string 34 gives you a quote. If you print ASCII quote, it gives you 34. So if you want to do it backwards or forwards, either way. Then you have EBCDIC, which didn't take off, or at least not in any way that I'm familiar with. It's kind of like the competing things against VCR against the Betamax or whatever, or 8-track versus the cassette. It's basically two slightly different ways of doing pretty much the exact same thing, and one of them sooner or later has to survive over the other one through some micro advantage or micro detail, or maybe a significant detail, or what have you. So that's it. Assembly language, this is whenever we have the characters, again, that are built on top of the numbers to give relevance to humans. This is a sample of assembly language. The dark gray shaded area are the comments, like the // in C++ or the rem statement in BASIC, which I'll show you a little bit of later. The commands are right here. I don't understand it because I've never programmed in ASCII. As I was found online, some samples from assembly code. This is probably an array, but I'm not sure. It's just basically giving commands of human words to a hexadecimal value, like the 4A and 4B and 4C and so forth. So again, instead of having to memorize a bunch of numbers and charts and what does this mean in hex and what does this mean in hex, you're actually programming in terms that can relate to a human can actually understand. So the relevance is starting to have more of a human context to it. This is a sample of basic code. I wrote this. It was a menu. It looks pretty involved. It was very fun to do. I did this in about 1991. I could explain it, but it's not the point of this little segment of mine. This is just how it actually looks. The line numbers right here. This is the very end of the program, by the way. The program is longer than this, and here's how the code looks. It's a bunch of commands. You're giving instructions to the computer. It's like a recipe when you're baking a cake. Don't be intimidated by it. Don't get discouraged if you're an aspiring programmer. If you want to know more about computers, don't do it. Okay? It's just you get to learn it. It's just like instructions on baking a cake. It's like following instructions with when you're putting together a home appliance or trying to turn it on or something. No big deal. Okay, here's some more code. Now, if you get to this next step, I highlighted the areas. This brings me to another point of mine to show the difference between low-level and high-level programming. $$ equals cracked by the dungeon master, which is a variable known as a string variable, means an array of text, a section of word, or word, section of whatever. A is the length of $. Is how long the phrase is in characters cracked by the dungeon master. So it's umpteen characters or whatever. And right here down on line 65, I have these highlighted and circled as well. We're going over to the middle of the screen, which is 40 columns, which would be 20, and we're going backward to where the beginning of the phrase would start. So the phrase would end up centered. You want to do this in HTML, hypertext markup language. Center, hello everyone, /center. And there you go. So there's a whole lot of relevance here because you're giving human commands to a machine that as software evolves and as hardware evolves, machines get more powerful, it's able to do the behind work or behind the scene work for you. You just tell it directly what to do. Start centering, hello everyone, stop centering, like you're talking to a person. So this is very, very relevant in the computer world because you're trying to make things as easy as possible for programmers and even average people. So let's see what we got next here. Oh yeah, this is a section of some maybe Visual Basic code. Here's your line numbers, which you don't need, but it's just uses for a reference. Dim statements, you got to declare a memory before you use it, which is left over. I think you had to do that in the Pascal programming language, as I was told. And back in the old days when computers had limited power, I think they do now, but not nearly like back then, it's not a big deal to declare a memory now, as it was maybe 20 years ago or something. You have the if, then, if statements, if statements. Basically, if this certain scenario exists, then do this. End the if statement. So in other words, only do this if this scenario exists. If this scenario does not exist, don't do it and skip this entire section of code. Very, very handy function. Very, very cool. Okay, this is some C++ code. See the double slashes here means a comment. Notice the comments are colored green to show the difference between comments that you leave for a human to read who later goes to look in your program 6 months or 2 years later than for the actual machine to execute. Very, very handy function in the programming language, the comments. The rem statement in BASIC has the same effect. Rem being short for remark. Okay, right here. In the Commodore, if you wanted to put a quote in the corner of the screen, you did poke 1024, 34. If you wanted to make the border black, you did poke 53280, 0. Again, it sounds like you're talking to a machine directly in the machine code. On the Apple, if you wanted to start like in the 4th line of the screen and make a 12 character long, basically line, you did something like H-line or print H-line 4, 12. I barely programmed the Apple a little bit in high school, like in '91, so I don't know much about BASIC in the Apple. And the Atari 400, which was less powerful than the Commodore, at least in memory, because it had 16K, where the Commodore 64 had 64K, you actually used the command set color. And I don't know what the third thing or what, but like one of them was maybe the screen or the cursor or something, and one was the color and one was the color around it, maybe, or something. But it was 3 of them. I do remember that. It's a little weird. Or maybe the shade, like a 6-degree shade of color 2, which was 4, or whatever. I don't know. Again, relate the command to the user instead of relevant to the computer's memory locations. See, this 1024, 34, these were memory locations of the computer. 1024 was a corner of the screen right here, and 34 was a quote, where the ASCII code for the quote. So again, we're trying to go up. We're trying to get away from talking to the machine in raw numbers and trying to talk in human terms. It's easy for average people and for programmers to understand and relate to. You wanted to delete a file in DOS, you do delete file, DEL space file. In the Commodore 64, this is the abbreviated version, open 15, 8, 15, S file, close 15. Okay, very long array of junk to memorize. Human commands. Same concept in object-oriented design, which is basically you're trying to give variables the same values as the things in reality that you're making the programs for. So you don't just have x equals 3 or x $ equals hello, you'll have student.age equals 16, student.name equals Brian, student.GPA equals 3.5. So you're giving multifaceted variables, which are now called objects, into that. So you're having more relevance in the real world than just trying to communicate directly with the machine with a bunch of ones and zeros. Oh, I made a full loop, and there you go. Here's the concept of interface. The person or the user going to the machine and going to the information the machine is interfaced with or handling. You usually don't think of the machine interfacing with information in a broad sense. Is basically what it is. So it's not just trying to have things like the graphic user interface, the mouse, the icons, but to actually manipulate information, what I call mass information handling. And here's a little deal that I concocted a while back. Basically like a bending bow and arrow. The more you have progress with something, the more groundwork you lay to have more progress based on top of that. Now these two ends right here, if they were flat and a flat bow, would have never been able to have touched this red, let's call it string or something. But when you bend at this level, these two ends get closer together and it's able to get these red, let's call them strings, done, touching each other and stuff. So it's just basically a visual way of trying to say, like, you know, warping space or melting plastic or bending a bow to tie like a bow and arrow or something like that. So anyway. Notes here, extreme and personal interface. The whole point I'm trying to say is that there is a need for communication with the machine to be less stoic and robotic and more human and personal, or personable, I think is the word, maybe a little more accurately. I have a little video of going through the Commodore 64 emulator and going through clicking on the mouse. I'm going to do that later on. Virtual IRQs, the concept in XP, Windows XP, that instead of communicating directly with the motherboard, the devices you plug into the computer on the outside, like a webcam or a scanner or a printer, are going through the software and then to the motherboard in a far less direct way. So you're able to, in effect, emulate 256 IRQs instead of the 16 the motherboard physically has. So it's a very, very cool, very, very awesome concept. The same concept in object-oriented design that I referred to earlier. And when you have more power of a machine, you're able to take more gloss on it. The Commodore 64 did have a GEOS, Graphic Environmental Operating System, or something like that. But compared to, 15 years later from that, Windows XP or Vista or something, it was nothing. But my point is to all this is that the more power you have with the machine, the more user-friendly it can get. Simpleton relative timelines, and I'll get into that later. And then there was a reference to my A+ book that cited that when people were able to do their own colors and fonts inherently in a document, I guess as it is today, things always got messed up and screwed up because everybody was scattered and they're on the same page, not on the same page. So the same deal is kind of what happened with Linux or different versions of Unix, and Unix has about 100 illegitimate cousins. So it's like people are all communicating with each other like a bunch of scattered tribes instead of one gigantic unified page. I'm going to get into the relative timelines later on too, what I mean by that. Okay, here you go. Intersecting surfaces, a plane with basically a sphere or it might be a parabolic sphere, I'm not sure, whatever. Oval, an egg or whatever, tip of an egg. Whatever. Here you got some shapes and things going on, colors and shapes. Ooh, junk. Equations for shapes and this, integrals, and those kind of stuff. Yada yada and whatever. Okay, this is square root something, three-dimensional. There you go, the Enneagram. Here's what I'm talking about. My case is I'm trying to make the VR interface is that you're trying to give color, size, and shape to human concepts. I think I have one in the next. No, that's a Kersey. Here we go. The peacemaker, challenger, enthusiast, thank you, loyalist, investigator, individualist, achiever, helper, and the reformer. What happens is that as mass information handling is going more graphical, I'm trying to make the case that when you have shapes and figures and colors put in the forms of charts, and then objects that are able to be manipulated, you have an interface that's starting to resemble in the same formula as the mouse and pointer and icons, how text was handled that I showed you before with the Commodore 64 emulator. So this is where I'm going with all this kind of stuff. And hey, yeah, that's a repeat. Calibration template, I call it. If you answer something like 500 questions, the search engine displays information formatted as to how someone like you would be best fit. You have the right brain, the left brain, creativity versus the analytical side, or the more technical or linear side. And I have a Science Digest article from 1965 that talked about someday computers will be able to handle gigantic amounts of information to tie to psychoanalysis. And it was so freaky because that was something between my dad and my uncle had when they were kids, or young adults, like maybe 19 or something maybe. And it was saying the exact same thing I've been saying for a while. So somewhere out there, a couple of us are on the same page. Next thing, the idea of coming from maps of a person or a subculture, connecting subcultures to certain fields. Now I have the idea that, let's see this one here. This is something I concocted a while back. I could babble forever on a lot of abstract ideas, but basically I'm trying to say if you research enough gigantic amounts of information, like I'll compare the middle class nerd subculture to the subculture expressed like in gangster rap or something. I found common elements like you have Judas figures, you have hero figures, you have the docile conformists, you have the people that are sociopathic or psychopathic, you have a struggle between good and evil in an alienated subculture, you have self-destructive elements within the subculture, and you have the idea that the more you resist against the forces that oppress you, the more you're hated and the more of a target you become. So when certain models like this can transfer to the same guys, like the Littleton, Colorado Killers, or like Ice-T or something, and there tends to be a lot of things in common about alienation and subcultures and stuff, trying to use models like this for mass information handling can get to a point to where you see correlation after correlation, similarity after similarity, to try to sum up mountains and mountains of information within a sentence. And I'm not talking about 900 articles, or Kirk, just use Google. No, I'm talking about 900 trillion articles. Something that will force people to go into a gist-only context. And there you go. That's the only picture I got here. Okay, here's my notes. Hardware versus software. Oh, yeah. Hardware people, engineers, and administrators, and so forth, are known for thinking more linear, distinct, and concrete in their thought. Software programmers, developers, and stuff, arguably in context, it's a little more artsy, abstract, hazy, not so clear and distinct because you're more conceptual with gray areas and fuzzy boundaries. I've tried to use the analogy. As you progress with hardware, like the development of an operating system over the years, like Windows NT to Windows 2000, 2003, 2008, a networking operating system, it comes to the point to where you have barriers and rules that reflect the limits of the hardware. Like there's only so strong a CPU the motherboard can take. There's only so much RAM you can put on a motherboard. There's only so much functionality that you can do on a certain OS, and that's it. One good example I remember about the teacher. The school I was at which I was, cited that Windows NT could flag a user for downloading a file more than 2 gigs, but they absolutely could not block the user from doing it, unless someone else out there knows something that they don't, but that's how I was told. Windows 2000 allowed you to do it. So as it progresses, the hardware OS progresses, networking OS, progresses, and hardware in general, you get more detailed and distinct in the rules and the barriers as such and as such. And then right here, now comparing hardware to software, notice that I'm using straight lines here to show boundaries, absolutes. Software is more hazy and abstract. You design software that's powerful enough to try to allow users to do something with it you couldn't envision, like art software and stuff. Or another example is that this hardware is the basis when you start with it, what to do with. You expand from the ability of the hardware with the software and try to drag it out, the boundaries, to try to make it as limitless as possible, or as close to being limitless as possible. Again, to be a little more visual, getting back to the visual theme here, hardware engineers, administrators think straight. A, B, C, D, F, G, H. Software programmers and developers might be a little more scattered. You have overlapping regions, gray areas, non-linear in thought, scattered thought, that kind of stuff, because you have to attack concepts. You have to attack the abstract. Attack the abstract. Okay. That's what you have to do. You're attacking an abstract situation, abstract problem. You're trying to crunch it down into bare bones of linear, executable instructions in a computer through a programming language to be later compiled into ones and zeros the computer can actually process. So it's tough to do, especially if you're not cut out for it. You know how the software mindset, I think it's very tough. I've talked to hardware people, networking people that hate Visual Basic and SQL and so forth. So another example right here, the fuzzy barriers I'm trying to convey, and also the non-linear. It's like a scatter plot and going all around everywhere. So it's, you have the A, B, C, D, E, F, G, H. We also have the scattered arrows and everything. Yep, there you go. My notes I had here, there was a piece on CNN where software was being invented to demand the high processing speed because average people weren't needing the most current computers being put out in the market. I heard for a while Intel was giving grants to people to have software that would demand their high-end processors. The modern world, the whole dating thing, trend-based materialism. It's cool to have a certain name brand and all kind of junk, modern world problems. Now, I'm jumping subjects here, but it's all one big glob. Sex marketing, that kind of junk. Public relations, PR, make people buy junk they don't need. Subcultures, I was told by a doctor in med school, it's a cutthroat subculture. You have the jocks in the athletic department, the nerds in the computer science department. I had my teacher, Mr. Clay, who said that one of my coworkers, when I taught, he said his students, the electronics students, you were usually the kids who like to take their toys apart because they like to see how they worked. So I thought that's pretty interesting. And all this glob here that I'm getting into is that I'm sloshing through the subjects, but it's subcultures tend to lean towards a certain field. So I believe in free will, but sometimes we're hardwired to maybe tilt in a certain direction. Maybe it isn't the route you choose to go, but sometimes you have the extra edge. There might be something deep within you to bring it out of you. And also they had a piece in NPR one time that there was a big PC sales drop because computer hardware got so powerful and so fast that people didn't need the latest and greatest because the machine they had was plenty for what their needs were. There you go. Okay, next thing, maps of themes. I like to show layout, visual depiction of recurring themes behind information. I have the taxes picture here and the senator debate or something, senatorial debate rather. The senator disagreed with lowering taxes in his last session. You have the one word highlights here. You define it. Ambiguous need that can destroy or uphold a nation. I have it right here. Okay, here we go. All right. You have a definition. You start isolating terms. Define the terms and break them down. If taxes can destroy or uphold, you got to sublimate rules about the whole idea of taxes and people which make you say that. People are not always self-sufficient. Okay, that's a good point. In a world where everyone was self-sufficient, you wouldn't need to tax anything because everyone would support themselves. You wouldn't need to redistribute the wealth and share the wealth type thing. We don't live in that kind of a world, so that's a pro-tax argument. Next thing, government is inherently imperfect. Ooh, you got to watch out with that. Very, very libertarian. You got to say, well, you got to watch out now because don't just equate high taxes with prosperity. You got to watch out with that. The other wealth distribution is a double-edged sword, which kind of sums up these two right here. This is about basically both the edges. Okay, fine. This is a made-up abstract thing. X is one extreme. The blue circle is another extreme. and you have this go-in-between symbol type thing going on for it. Ambiguous need that you're not sure what is the denominator of the context, but you have socialism and capitalism between these two extremes. Socialism, government dependency, fiscal dictatorship, overregulation, and capitalism to an extreme, no help for the poor and corporate rule. This would be a summation of an argument grid about taxes. And there you go. Okay, let me see here. Oh yeah, now these shapes and figures, I admit they're arbitrary, but that's the point. If I had $1 billion of research in 20 years in an army of about 200,000 beta testers, which you just simply make that to public when you release your software, I'll be able to develop things to more concrete, that would more meaningful symbols. But my argument to this kind of software is you start with the arbitrary. You just throw the gauntlet down, you jump into the mess, and what happens, happens. Okay. I'll call this grid 19. You have the x-axis is which feature, rap, safer sex, anger to pass, political correctness, and so on. And you have the y-axis, which is how acceptable or how society acts toward it. And you have the different formats. FemForce 12, State of Q, and Bottom Line. You know, FemForce 12 is blue, so for a socially unacceptable rap, okay, finds rap, you know, whatever, FemForce 12 would be, you know, rap is whatever, whatever. The yellow right here, State of Q, like for mine, would be rap socially mandated, saying people need to listen to rap, period, you know, and you go on down that scale. Taxes again. Here's one to show pro-establishment versus the alienated and the disassociated. You might have moderates who don't like extremists. You might have extremists who don't like moderates. There you go. By the time you get to a certain point in the hierarchy in party politics, there's an argument. You have a lot of internal strife that's counterproductive. So that would be about up here. And within I was trying to show in this picture here a process of decay to show that the things actually implode. And when you get to a certain point, you actually have things in common with the zero mark. Like right here, 0 and 4 is almost the same thing with this kind of warped, imploded thing right here, like warping space. Some people argue extremism is a straight line. Others argue it's a circle. Or maybe a little more accurately, it's more like a U. The case behind this is that, or for this, is using the grounds for it rather, is to say that when you go far enough in one direction, you start to have things in common with the people you're the opposite of, or which you're the opposite. So certain extremists have things in common. You have a Ted Kaczynski or Timothy McVeigh. Ted Kaczynski was written off as the hard left. Timothy McVeigh was written off as the hard right, but they both blew up things and killed people. You know, certain stuff like that. Like there was a joke at one liberal website that said conservatives think that a right-wing dictator is better than a left-wing dictator. That's like saying pick your poison, so it's kind of funny. Anyway, here's one of my little charts. I call this the spider sheet. Things where me and Ice-T have things in common, or the compromised conservatism I call conservatism, courtesy of Bill Clinton and W. Bush. And it's just a way to throw information and give a look to certain things. Here's a little bit more of a three-dimensional graphical depiction of it, you know, spider thing, combined with a little tip drawing I did earlier. And, oh, I had this one for a teen sex thing. Tell teens to abstain and it won't work. And I changed this saying, if you blindly do it or do it easily and lax, it won't work. But if you do it with the proper tools, it'll work. And a lot of people say, well, that's not absolute. We're going to have this. It'll take a considerable revolution to try to address our sex-based entertainment industry, to reach kids, to build a context that exists so you have the proper tools to push abstinence to teens and to have that to work. So I'm trying to say stuff with pictures. Here's another thing about abortion or pregnancy. You know, initially it starts right here, then it evolves into here, the entire abortion industry, the entire abortion movement, versus the pregnant woman, the friends and family near the pregnant woman, all people who are touched only by the issues of abortion, the biological father, the general role of men, or pop culture and society's attitude of sex and reproduction. So it gets more broad than what you lay it out within a list. Here, I call this the shatter box. It's just a XY coordinate system, Cartesian system to plot different stuff out. PC, safer sex, establishment, libertarian, you know. Oh, there you go. Okay, the virtual reality body gear. This is how I want some of this stuff to look. Let's blow this up a little bit. There you go. My cyber grid, if you will, with the gloves and the goggles, grabbing everything and going through everything, you know. Giant Mnemonic, Minority Report, you know, if you've seen those movies, that pretty much caps it off. An aggressively organized information system like this, again, no two people would do the same research to have the same argument twice, what I call ideological combat over a three-dimensional grid. Interface is more personal. You're giving, you're building a context for interaction with the metaphysical. You're trying to give themes behind information, like I said earlier, color, size, and shape, maybe even sound at some points. Maybe even feel if you have like a force feedback thing in your glove, like a wire that jerks back when you do something right or wrong. And calculus, we had in the graphing calculators, it said that because you were able to graph with the calculator instead of having to plot everything by hand on pencil and paper, which took considerably much more time, you can start to see trends and gists behind information rather than messing with the raw data itself. So in other words, you're seeing the big picture faster. And a point I like to make that I've been making since the 90s is that virtual reality equipment with the helmet over your eyes and your head and the gloves, it looks like battle gear, because I refer to this not just information navigation, but also ideological combat. And so there you go.